Hi, my name is Tim Checketts, and this is BYU Idaho's digital submission for the Student Design Competition. As crazy as things are and have been, we are grateful that we can still participate in the Student Design Competition as we have put in hundreds of hours. So thank you. When we first started, we knew this was going to be a big challenge. In all the history of Student Design Competition, this is the hardest that I have ever heard of and didn't know how we were going to pull it off. So we started off with a pipe and some paper. Initially, we knew that we needed to somehow hold the paper together, fasten it to itself, and raise it up. We decided to tackle holding the paper together and fastening first. At first, we had a ton of ideas of how to wrap and fasten the paper, and so after much conceptual generation, we narrowed things down by concept selection with many of the other ideas in the back of our minds. With one of our first iterations, we thought we had a solution to wrap and fasten the paper. As the arms in the CAD model were pushed against a pole, it would wrap the paper around the pole, and then, using on the left the witch's finger, the paper would be cut and bent in on itself. Although the CAD and physical model were promising, there was a snag. As the arms wrapped around, the paper would not fold neatly, even with the redesign of the arms. Also, we needed the paper to be in position when that happened. We knew that we needed to go back to the drawing board, and so we explored another idea from our concept generation and a couple other ideas. During our concept generation, we had researched a stapeless stapler. Although we had thought the idea would be too hard and wasn't sure how would we use it, we decided to give it a shot. As we started playing around in CAD and prototyping, we realized that we could actually use the stapeless stapler more easily if the paper were in the shape of a taco rather than a cylinder. Although we had originally thought that a cylinder would be the best shape, we realized that for our design, a taco shape would be even better. The way that this would work was that a piece of paper would be inserted around the pole and then fastened and lifted. Following that, a new piece of paper would be inserted and attached to the bottom half of the first piece of paper and then lifted by the motors. And this process will continue until we had a fully built tower. Although the stapler was promising, the stapler had to be taken apart and reconstructed with very tight tolerances, a feat in and of itself. As we were beginning to get our stapler to work, we began to redesign and build and combine other ideas. As we had one part of the robot working, we knew that we needed to figure out the lift mechanism. So we designed a tower, as seen on the right, that would go around the pole and have motors, as seen on the left, that would rest on the poles and move the paper up. We realized, however, that an initial paper would have to be fastened and lifted in order to reach the motors. In order to combat the problem of lifting the first paper, an arm was designed and iterated, along with a slit cut in the pipe as a solution. Just as things were coming together and we were preparing for our full build, COVID-19 shut everything down quickly, and the school and labs were locked up along with our robot. Luckily, we had taken pictures along the way. Although we had hoped to finish and compete in a live event, we still accomplished a lot. We were able to complete our build in CAD, and before everything was shut down, we made a lot of progress on our build. Seeing our robot in action is what everyone had hoped for. We will end on watching our robot use the stapler to fasten paper together.
Ready? Woo!
Yeah!
Oh yeah!
Woo! Thanks for watching.